Hello and welcome to our demo video for our Pynini platform. Pynini is an IoT platform designed to improve the skills of any baker. The architecture is composed of 7 main components that we can see here on the screen. We will now focus on the catalog component. The catalog is used by all elements of the system. Sensors use it to retrieve information on which topics to subscribe to and database endpoints. The database API uses the catalog in order to retrieve its configuration information. The control system uses the catalog to understand which cases are connected and subscribe to the useful topics. We now move to the device connector. The system is equipped with temperature, humidity, and CO2 sensors. When each sensor is activated, it takes the following actions. It connects to the catalog REST API and retrieves broker IP and port, along with its topics and database API information. It contacts the database REST API and registers itself to the database. It then proceeds with its normal operation of taking measurements and sending these over MQTT. The ESP Arduino system is a master-slave configuration. The ESP is used to provide the Arduino with Wi-Fi connectivity. On startup, it contacts the catalog and registers itself and the Arduino to the system. It then establishes a MQTT connection with the broker. The Arduino houses the actuators, which include the fan, lamp, and button for bread type selection. ESP and Arduino communicate via the I2C protocol through polling and response. Here we can see how the Arduino, ESP, and breadboard are connected. The Raspberry houses the sensors and MQTT broker. Both sensors, as discussed before, use REST APIs to contact the catalog, and then, under normal operation, use MQTT to send messages. The Raspberry also acts as the control center for the system. For every message received, it applies the control strategies found in the control system. The control system. It acts as the brain of the operation. It subscribes to all topics for each different case in the system. It makes decisions based on the messages sent by both the sensors and takes in consideration also which bread type has been chosen, changing the various thresholds need there be. The database. The database module is made up by both a REST API and an MQTT client. The REST API serves the function of registering which sensors have connected to the database, while the MQTT client receives the different messages published by the sensors. Regarding our microservices, we provide two types. The parameter control microservices check the different variables of the system and generate control events. Parameter regulation microservices reflect the different policies through which the system is maintained. Now we move on to ThinkSpeak and user awareness. We use ThinkSpeak to collect data from sensors, Freeboard to visualize statistics and case information, and InfluxDB to visualize data coming from sensors. As we can see, ThinkSpeak provides us with different measurements for the different sensors, while Freeboard provides a more dashboard-like experience. Similar measurements can be found using the Data Explorer of InfluxDB, where we can see different types of measurements for the different sensors. The Telegram bot allows the user to select a specific case, choose the parameter to analyze, get the real and the best values for the actual type of bread of the case, reset the thresholds of the specific bread topology, and get information about the actual bread topology through a link stored in the InfluxDB. Also Dockerize the different components in order to provide scalability to the system. Thank you for your attention, and now we will proceed to the visual demonstration. In order to start the system, we first build all the different Docker images which are necessary to then build the Docker containers. So as we can see on the screen, we are building one by one the different images, starting from the catalog. Now moving on to the database. Next we have the CO2 sensor. Along with the temperature and humidity sensor. Finally, we have the controller. Now we have to run the different containers that we will create given the images we have previously created, as we start from the catalog, moving to the database, then to the CO2 sensor, and we can see the case ID which we have given. Next we can go to the temperature and humidity sensor, and also here we can note the case ID. Then we also build the second case with a different case ID, with both CO2 and temperature humidity sensors. Finally, we build a controller which will control both cases. Here we can see all the devices that have been registered to the system, all the requests they have made to the catalog. Here we can see the ESP Arduino module connecting and reading data from its memory, and we can see in the background terminal that has connected to the catalog and it has registered itself to the system. We now move to the InfluxDB cloud database. As we can see, we have all the different measurements for both cases, and we can simply zoom on the values and we can see the unit of measurement, category, case ID, the various measurements, and the time at which the measurements were sent through the MQTT broker. Now we show the effect of the button change that gives the different bread type. As we can see on the terminal and the highlight, the bread index has changed, and also the measurement taken by the CO2 sensor in this case has changed the category of bread. Next we move to our Telegram bot. We start the system by the start command and then select the case we want to investigate. We are given different commands for temperature, humidity, CO2, and going back. We can then have more information, reset thresholds, or go back to the main menu. As we can see here, we have reset the temperature, and we have also asked for the When it's time for shutdown, we simply exit all the different sensors. As we can see, the sensor sends a post request to the catalog in order to remove itself from the system. This is done for each sensor for each case. As we can see, the catalog is still removing different sensors. We move to the first case. We also see here the different sensors being removed, and also the sensors are removing themselves from the database using the database API. This is done in order for the database to know which topics to subscribe and not subscribe to. This concludes our presentation. Thank you for your attention.